Welcome to the GOTO podcast. In this episode, Simon Brown, Dave Farley, and Lowette cover some of the recent trends in software architecture, like DevOps and how to deal with complexity. They also reference concepts that have stirred debates forever and are still not done right, like bounded context and continuous delivery. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events, held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hi, we're here at GOTO Copenhagen today. My name is Hannes, and I'm here with Dave and Simon. Maybe you guys can introduce yourselves for a little bit?
Yeah, so I'm Simon Brown. I'm an independent consultant specializing in software architecture. And I like to talk about software architecture and how software architecture fits into the modern agile ways that we work, and especially diagramming. That's one of my big things.
Hi, I'm Dave Farley. I'm also interested in software architecture, but software development in general. My big thing at the moment is thinking in terms of software engineering. What does it take to build better software faster? But part of that is certainly software architecture.
Maybe a quick one to start with. What do you think like the most positive evolutions have been like the last maybe sort of decade in terms of software architecture? What has enabled you to do better things? What are the big thoughts that have changed?
I'm going to say DevOps and pass it over to you immediately, because I think that's a huge one for me.
I think, without being immodest, I'm connected with continuous delivery and DevOps to some extent. I think that is one of the things, in part because of the stuff that I was touched on in my introduction, which is that I think it's real engineering for software.
Yeah.
And if it were really engineering, it would allow us to build better software faster, and it does. That's what the data says. So we can do more sophisticated things, I think, using those kinds of approaches, those kinds of tools, that kind of thinking.
Yeah.
So I'd agree with that, although it sounds rather self-serving coming from me.
Yeah, no, I definitely echo the same thing. If you look back 10 or 20 years ago, teams were really struggling just to get stuff into production, and there were lots of manual steps. And with continuous integration and continuous delivery and all the DevOps stuff, that's optimized and automated a whole ton of stuff. And I think that's one of the biggest things you can point to over the past couple of decades. It's really allowed teams to move faster. And with more of an engineering discipline, actually doing things that are a little bit more formalized and structured than they perhaps were at the start of the 2000s.
I think that's true. I think in parts one of the ways that I think about this is that Agile was a step forward. Agile, no doubt, Agile was a step forward. It also took allowed us to make some missteps. But I think bringing
You're talking about SAFe then?
Not only safe, but certainly safe is a culprit. But I think some of the missteps is that I think Simon would agree with this, is that it made everybody think that you've got to throw your brain out and just start from scratch with everything. It doesn't stop us designing. It shouldn't stop us designing. It shouldn't stop us thinking deeply about the systems that we're going to build.
So you see lots of developers that think we don't need an upfront design or architecture anymore because we're working agile. We can push features out.
There's a very big difference between the failure of big upfront design, which Agile countered, and design.
Yeah.
Agile, to my impression, Agile is about doing lots more design and taking design more seriously, not less. I don't think you build a complex system in one giant leap springing from your brain.
No.
It's an iterative, incremental approach to evolving complexity and systems over time. And part of DevOps and continuous delivery is to allow for that evolution safely and in a controlled manner.
Yeah.
Is that what you think a good architecture does? Is support this iterative approach, support the quicker delivery of new stuff to production? That's what a good architecture does, or is there more to it than that for you?
Essentially, that's exactly what a good architecture does. People say that the Agile Manifesto doesn't talk about design, and therefore you should not do upfront design, to kind of echo the same thoughts. And I've seen teams go from big upfront design to basically nothing, and they've realized that's now also a bad idea. And in order to move fast, in order to embrace change and deliver stuff quickly, and use all of the DevOps tools and the CI/CD tools to kind of move fast and deliver stuff properly in a structured, more engineering-based way, you need a good design. One of the principles in the Agile Manifesto actually says a continuous approach to good design enhances agility. You don't get a good design just by hacking code for free.
Yeah.
No. You have to put some thought into it. And although I completely agree that we need to think about stuff in an evolutionary way because we're going to get changes and we need to pivot and change direction, I think you still need a starting point. Not all of the starting point, but a starting point with some principles in place, so that allows you to create that good structure, high degrees of modularity, so you can move fast. So yeah, it's a blended approach.
So I feel that you're saying that your design should evolve with your product and with the things that you learn from pushing stuff out. But you mentioned you want to get some stuff in place in the beginning already.
Hold on. He didn't quite say that. If you forgive me if I'm putting words in your mouth. What he said is that you start off with a model.
Yeah.
You start off with an idea for what your design might be. I would couch that from an engineering principle, is that you start off with a model like that and assume that it's wrong. Okay. That's the step to engineering to me. Yeah. So you assume that it's wrong, and then you work in a way so that when you find out where it's wrong, you can correct it.
Yeah, right. And that's very different to big design up front, because when people did big design up front all those years ago, they assumed they were right, and they assumed that set of blueprints they come up with was the thing they should always aim for. So I think we're saying have a starting point, but be prepared for that to change. And of course, DevOps and CI and CD give us the tools to make those changes easier if you have a good architecture in the first place.
Yes.
Okay, so what is the stuff that you would focus on first? Like if you know where you want to go in the long term and what kind of architecture you would need, what kind of design you would need to like support the final product, but you're not going to build all of it at once, right? What are like the non-negotiables? What's the stuff that you always need, even if you start out with your first version that you're pushing out?
Do you mind if I take that first? Because I think I can set you up for fleshing more detail. So from an engineering point of view, the things that I would describe are all about managing complexity. Right. I would start to try and identify ways of compartmentalizing the system so that I'm able to understand the pieces and change them without affecting other parts of the system. Right. And I would say that's a deeply profound and important aspect of architecture and design. And then, that if you're able to do that, so if you're able to build systems that are more modular, more cohesive, good separation of concerns, good lines of abstraction, tending towards being more loosely coupled between those pieces, that's the kind of defense that you then have to allow you to find out you screwed up and made a mistake and change things and make the code a habitable space that you can change. And I think Simon's stuff, as I understand it, takes that, gives you tools that allow you to achieve those kinds of ends. Yeah,
I was going to say, it's literally the same thing. So Grady Booch has a great definition about software architecture. He says software architecture is about the significant decisions. Yeah. All of that stuff is significant decisions. It's your key tech choices that you can't really change later. It's your overriding modularity strategy, whether you're building a monolith or some microservice or something in between. And again, it's how do we make this thing so that we can change it in the future without having this horrible blast radius effect that, you make change here and everything blows up. Yeah,
and I'd argue to some degree that architecture is nearly all about that management of complexity. Yeah. It allows us to build systems that are beyond the scale that we can hold in our heads,
or at least a part of the system that you can hold in your head.
Yeah, right? Where you compartmentalize it so that each piece fits in your head.
We've seen a lot of the practices from the big players that have moved into the common domain. If we look at technologies like containers, orchestration, more than ever, the ways that we can do pipelines has been commoditized. You can do that on so many platforms now. With great power also comes great responsibility. Do you think that people are hurting themselves with these technologies as well?
I do.
Yeah, I do too. There's an elephant in the room, so let's name the elephant. I think that people get microservices wrong all of the time. I think that microservices have become... Most of the clients that I'm like Simon, I'm an independent consultant, and most of the teams that I see that claim to be adopting microservices aren't, by the definition of microservices, doing so. And where they start is, if they're starting something new, they start by assuming that they understand what are the services, setting up creating a separate repo, and then starting working each of those things. What they've just done is built latency into the point at which they want to iterate quickly in order to be able to learn. Yeah. So the other aspect of engineering is to optimize for learning. So you want really fast, clear feedback. If my service is in one repository and Simon's is in another, every time the conversation between those services changes to the smallest degree, either I've got to go and dip in his, or he's got to dip, and it's a nightmare. If we put them all in one big repo, we still have nice service-oriented designs, yes. but probably 90% of the time, my IDE will tell me that I've screwed up his service.
Can you do that? Can you take that a step further? And when you're starting out, team is still small, company is still small, not just put it all in one repo, host it all in one process. Or do you think that's a horrible idea?
No, that would be my recommended starting point for 95% plus of teams out there.
Yeah.
I actually did a talk at a GOTO conference, I think it was a GOTO Berlin a few years ago, called Modular Monoliths. Same thing.
I have a very similar talk.
Yeah. I think there are a few people now with talks that they're finally becoming fashionable again. I've seen the same thing, a whole bunch of people who've got this 10, 15-year-old Java legacy application. It's a horrible mess. It's brittle. They can't change it. And they say, we're going to convert to microservices. And what they do is they take their existing design thinking, their approach to modularity, which is not very good because that's what got them into the mess.
Yep.
And they basically stick JSON over HTTPS network links between things in their monolith.
That could have been in-process calls.
Right. And now the boundaries are wrong. The boundaries are hard to change. And you've got something which is lockstep deployable, brittle, fragile, and slow. And they just don't get, there's a very different mindset shift there.
Because don't get me wrong, at a certain scale, you're going to want separate services. But
maybe, Facebook, Shopify, there are some big modular monoliths out there. Shopify have got a huge big thing on their engineering blog over the past few years about how they've changed their Ruby on Rails monolith to become much more modular because they were running into issues.
I'd argue that modularity is always good, but not necessarily. You don't necessarily need inter-process communications all over the place, and often you don't need multi-threading in lots of places where people put it. And that all of those things, both of those things, amp up the complexity by an order of magnitude at least.
Not just the complexity, also the how hard it will be to debug, how hard it will be to trace,
and even just deploy.
Just to figure out what is my software doing in production, that becomes extremely hard. Is that something that you take on from the get-go, visibility of your systems? Is that something that... Because to me, that always felt like one of the most important issues that a lot of people seem to be forgetting.
This is why some big organizations who are very microservice focused, they give their teams autonomy, but they have internal engineering and platform teams that bootstrap the product teams and the service teams. So literally you can pull something out of their internal repo, bootstrap your service, and you get observability free and monitoring for free and deployability for free into the production GCP environment, and all of that stuff is taken care of you in a standardized way, and that's fabulous.
The other thing is that microservices give you, if you do it well and at scale, is it's the most scalable way of building big systems, because what you do is that you trade off consistency for independence. So this is the most distributed approach to development, but it means that if I'm writing a microservice and Simon's writing a microservice, I can deploy mine without testing it against his. That's how good the abstraction is between them. And that's kind of table stakes. You can't really count it as microservices if you can't do that, because that's the decoupling step. Yeah. The point at which we no longer care about the details, and that means the protocol's got to be stable between us. So you've got to be fairly sophisticated in design terms to be able to get to those stable protocols.
But that requires some really competent architects, because that requires both business knowledge and technical knowledge to define those boundaries in the right places, because otherwise they will be working against you.
Yes.
Right?
And that's why most teams should not do this, because it's hard.
Yes.
Exactly. Are there any tips that you can give people who are starting out in this?
I go talk to Sam Newman. He's got a ton of tips out there, a couple of books.
Yeah.
I talk about a few things. So I think that one of the other defining as well as independently deployable, the other defining characteristic of microservices is that they're aligned with the bounded context, and there's a good reason for that. So bounded context is an idea from domain-driven design, which there's an area of the problem in which a concept is distinct. You might have the same. So let's imagine we're buying books. The shopping cart's going to have the notion of a book. Yeah. And the inventory control is going to have a notion of the book, the delivery.
It's a different book.
But it's different. You need, the delivery probably needs to know the weight of it. The shopping cart probably wants to have the picture of it or something, the detail of the author or something. They're different, but they're talking about the same thing. But so that's the difference between two different bounded contexts. So if you align your services with a bounded context, those are naturally more decoupled points in the architecture of the system. It's not 100%, but it's a good starting point. You're likely to get away with it more if each of these services is aligned with these bounded contexts rather than not, I would argue. And then you need to still go back to what we were saying earlier. You need to iterate fast to find out all the ways where you screwed up and you got it wrong and you got the communications too tightly coupled until it's stable, and then you can break them out.
Yeah. Is that something you look for in your architecture as well? Is this alignment, because you brought up DDD, this alignment between what the business domain is and what you actually see represented in code?
Sometimes, so I'm the creator of the C4 model, which is a hierarchical way to draw architecture diagrams. Yeah. And one of the questions I always get is there a one-to-one mapping between things like a bounded context onto things on the software architecture diagram? And sometimes there is. Sometimes those concepts, as you say, do map really nicely. And other times you'll often find a bounded context spans multiple software systems or perhaps multiple C4 model containers like different services. So that whole mapping between the domain world and the architecture world, the technical aspects of the architecture world, don't often line up. And I think that's okay. Yeah. But I think people perhaps need to appreciate that that's not always the case. And there are too many people saying, I must have a complete one-to-one mapping between stuff in DDD and stuff in my architecture.
Well, it's a nice utopian image, but I've never seen it in reality. So
no, me neither. No.
I think there's another aspect to this in which I think a lot in terms of the separation of accidental and essential complexity in architecture, and my ideal architecture, I'm going to have little bubbles of domain logic that know nothing about the accidental complexity of the system. And then I'm going to build the accidental complexity, persistence, clustering, durability of messaging, all those sorts of things into the infrastructure that supports those services, and therefore they're isolated from it. That gives, if you can get to that gives you a fantastic degree of flexibility and freedom because you're simulating the problem domain in your domain logic. Okay. That leads you on to I was involved in writing something called the Reactive Manifesto describing reactive systems, and I was involved in building a financial exchange on the model that I've just described, and it was the most beautiful system to work on big system that I've ever seen, because you could each of these little bubbles of domain logic was single threaded, so they were dead simple, they were stateful. You didn't have to worry about anything, and everything else was persistence, clustering, scalability. All of those things were resilience were outside.
Were out of the code base.
They were not out of the code base, out of the domain part of the code base.
Okay. Is that one of the things that I've been playing with? Is like the distributed application runtime Dapper. I don't know if you've looked at that.
I haven't looked at that. No.
Okay.
So the closest commercially available stuff to it that I've seen are actor-based systems of one form or another. Erlang, Akka, Oracle, those kinds of things. Yeah.
But the cool thing, what they do in the Dapper is you write your services against a package that has a couple of abstractions. You have abstracted key value storage. You have abstracted messaging. Based on logical endpoints. But all of it in your code is abstracted, and on your development machine you could run the services. it works on Kubernetes with sidecar containers. So you always talk to the sidecar container, and that talks to the other services through gRPC.
I think what I'm describing is a step further in abstraction than that.
Even further than that?
Yeah.
Okay.
So for example, I could have an account service that took a message that said create an account, and it would create an account in the internal state of the actor, and it would send out a message maybe saying account created or something like that. No storage, no persistence anywhere else, but no notion of a database. But it was in the messaging, so I could just record the messages and then replay the messages and that kind of thing to get back to the same state, because you get these deterministic
so thinking about things in an event-sourced way, and the state is a result of events.
That's part of the persistence of state is part of the accidental complexity. It's not the only, it's not the only architecture. Of course, that would be a ridiculous thing to say, but it's a very nice one, and I think I've just made a video on my YouTube channel about this, but I think coming up in a few weeks. But I think it's an interesting idea in terms of further abstracting the cloud. So there's moves towards stateful serverless, and they're not doing it very well yet, in my impression. But I think that if you could imagine something like that, you could imagine kind of offloading a lot of the accidental complexity to the cloud services, sort of further raising the bar. Because not everybody is an expert architect, and not everybody needs to think about all of those things at the level of detail that we do at the moment, potentially, I think.
But perhaps they should do. I'm going to rein this conversation back in a second, because although I'm a big fan of abstraction, and particularly abstractions leading to high modularity, do you remember enterprise Java beans from all those years ago? So we had remotable enterprise Java beans, and then somebody said, well, we could put that same thing locally, and you could use the same interface, and you could have a local and a remote call. And that abstraction was fantastic, but many people tended to forget that actually there could be a network call here at runtime, which would have massive performance impact. So I think abstractions are great, but development teams do need to understand what those abstractions are and what the trade-offs of those abstractions are. And to come full cycle back to the earlier conversation, that's exactly what your architecture is about up front. It's like, where do we want these network hops, and what are the trade-offs?
Absolutely.
Okay.
I wouldn't disagree with that at all.
I would have done the same thing, but in WCF and not enterprise.
WCF, same thing.
But it's the same. It's the same story. I'm a C# kind of guy, so. In the recent projects that you've done, what are some takeaways that we can get, like, above all, check that you don't do this? What was like the single move that you see a lot that ends up hurting people?
So from my perspective,
apart from microservices,
apart from microservices. From my perspective, is people just jumping on the first solution they come to and not really considering the trade-offs. So that's why I'm a big fan of doing some design up front, and also having a good, simple way to visualize your potential starting point in that potential architecture, because then you can evaluate it, dry run it, review it without writing lots of code. So it's make sure you have a clearer idea of your starting point before writing tons of code.
I think I've got two. So the first one is kind of, I think, echoing what you've just said, Simon. My perception of most software systems that I see is not that they're badly designed, is that there is no design. They're just kind of big balls of stuff. There's no obvious organising principles that you can
file new
discern.
project. Let's start hacking away.
And that's problematic. There's no management of complexity. You just got a big ball of mud. And so I think, as an industry, we don't talk about design enough. We don't do enough design. We don't think about it. We argue all the time about whether it's C# or Java or whatever else. That doesn't matter as much as good design versus no design or bad design.
Is there maybe a problem in our industry then, in terms of
more than one?
Yeah. I agree. Let me finish the question. It's about the way we communicate about things.
Yes.
Because you see lots of conferences where we talk about latest version of tool X, or like this small building block and so on. And then you have the very high level stuff. Like, on a big scale, we want to be doing this.
Yeah.
But in the lifetime of a developer, from when he graduates college until at the point where you guys are at, like expert architects, there's so many steps to take, and there are skills that you need to learn. But I feel like the path there is not something that is often communicated, and that a lot of the blocks in the middle, like the run-of-the-mill solution architecture for small to medium enterprises, is something a lot of people have to learn on their own, because there's not a lot of communication about it. Because those are not the sexy subjects to give conference talks about, for instance.
Yes. That's why we have so much work, is because there's a complete lack of any fundamental teachings and training and skills in most organizations. And you're right, when you come to conferences, all the new hyped trendy stuff sells. Our stuff, it's not boring, but it's kind of the essential fundamentals that people really need to know, but it doesn't sell seats in cinemas.
If you'll forgive me mentioning one of your competitors, I won't name them, one of your competitors in organising conferences.
I don't work for Triforce.
No, he does over there. One of your competitors had an adoption graph I saw a few years ago. And it was talking about all of these new sexy technologies and all this kind of stuff, and the early adopters doing these sorts of things, and the late majority was where continuous delivery was, and I just kind of fell on the floor laughing, because I was just saying, really, you think that's what the state of the industry is, that the continuous delivery is normal? It's not. What most organisations talk about in terms of these engineering disciplines and continuous delivery.
What do they say then? Because they have a pipeline to deploy their stuff, they're doing continuous delivery.
Yes. If you're in Jenkins, you're doing continuous delivery, and you're not. Continuous delivery is working so your software is in a releasable state all the time. That's it. And if you adopt that discipline, it drives you in this direction for being much more disciplined, caring much more about design and architecture and all those sorts of things. Because you can't do it if you don't do those things. It's just not feasible. And I think, and we don't have many things like that, which is why the engineering thing. Because if we came up with something that genuinely counted as software engineering, it would make us build better software faster. Because if it didn't, it wouldn't count as engineering. Continuous delivery does that. That's what the data says.
But you cannot do continuous delivery without having your team involved in
you can't.
Running the system in production.
Well, you can. You can do that, but it's not optimal. It's better. You need them. What you need to do is you need to close the feedback loop.
Yeah.
So you need the team to be monitoring, understanding what's happening in production, even if there are other people that are looking after it.
They don't have to set everything up, but at least they have to not. Like in the old days, like we develop a system, throw it over the wall. It's Ops problem now.
So my advice for I'm steering us off topic, which I apologise for. But my advice for continuous delivery is that you aim to get to a releasable state once every hour. You can't do that if you don't have a great architecture, and you can't do that if there's waste in the process. You've got to remove waste out of the process. So every time there's a handover between different groups of people and stuff like that, that's waste. So you have to get down to these small, focused teams to be able to do this, and they need to know a lot of stuff. Trying to drag this back to architecture for a minute, I think that one of the problems in our industry is that we get so blindsided by sexy technology.
Yeah.
That we lose our focus. I
saw some speakers call it, and it's a term I've always used as well, call it magpie development.
Yes, like shiny things.
Like the shiny thing. Ooh, shiny, I want to have that, I'm going to use it, whether it's appropriate for my problem or not.
I did a little exercise recently for a book that I've just finished writing, where I wrote a simple CRUD application in the latest sexy web technologies, and I wrote one in the technologies of 1995.
Okay.
And in the code that I wrote and needed to do the same job, there was about a quarter of the code in the technology of 1995 as it was in Angular and that tool set. Now, the Angular stuff gave me stuff that I didn't have in the 1995 version. It gave me more browser independence and all those sorts of things. There were some benefits.
Yeah.
I'm not saying there's no progress, but there's nowhere near the progress that we assume that there is, because we're too close to the hardware, and they've got this exponential progress. We don't. Yeah. Software development doesn't move at that pace, and there are fundamentals that matter.
So because that's something that has bothered me about, we're in the consulting business in Belgium, and DevOps has become a job title or a function description for someone. I mean, we need a DevOps guy. What's your take on that?
Oh, it's the same old story in IT. Something comes along, there's a lot of good stuff behind it. The masses get hold of it, don't really understand it, and just copy what they think it means. We've seen this with Agile. We've seen it with everything, haven't we?
Funnily enough, if you forgive me touting my YouTube channel, I'm publishing a video on that topic this evening on my YouTube channel, 7 p.m. UK time. But one of the things that I say in that is I've been fortunate in my career to be close to the birth of some reasonably significant ideas. I was involved with the people that invented BDD and DevOps and a whole bunch of things. And my biggest takeaway from what's going through those inventors' heads, those creators' heads, is we didn't mean that. There's this kind of dilution effect as ideas become more popular. Everybody just kind of reads the words and just assumes that they know what it's talking about. Everybody thinks that continuous delivery is about deploying stuff into production all of the time, frequently. It's not. It's working, so your software is always in a releasable state.
Yeah.
Everybody thinks
and getting the whole team to care about that.
Yeah. Everybody thinks that microservices is about having little things talking REST APIs in a separate repo, and it's not. It's nothing to do with those things, and they're all like that. And I think we fall down. DevOps is I dislike the DevOps. I'm sometimes referred to as one of the people that helps popularise and create DevOps, and I do dislike the DevOps term because it's so easily misunderstood. But the ideas are absolutely spot on. The practices are extremely good. DevOps evolved. Continuous delivery started a little bit earlier than DevOps, but they co-evolve from different angles. DevOps coming from operations, continuous delivery coming from development, and they met in the middle. They're talking about exactly the same ideas to a large degree.
They can only meet in the middle if you understand both sides of the problem.
Which is what the whole thing was about in the first place.
Exactly. It's like bringing the two sides
across the wall. It's exactly what it's designed to
take down the wall, make it one team. That's what it's about. Not about we need to hire a guy that knows about Puppet and Kubernetes. And
No, it's not.
Which is what this has turned into in many cases.
This is what it has turned into, sadly.
Yes.
Sadly so. Yeah. Okay, so in Alan Kay's opening keynote, he was speaking about and drawing some similarities between the software world and the world where they build big structures. You have an architect that designs the whole thing up front, but then you have the engineering teams that have to come in and actually execute on the architecture and make it so that the bridge doesn't collapse when you're driving your car across it. In that world, those things go really well most of the time, and in software we seem to be doing a terrible job.
Yeah.
Are there any engineering takeaways from an architecture standpoint that we can give the audience to incorporate in their software systems?
I think that there are. That is my one of the themes, the theme of one of my talks at the conference, to be honest. So I'm touting my own wares, but I think that ours is a discipline of discovery and learning, so we should be optimizing to be experts at that. And ours is a discipline of managing complexity, and so we should optimize for that. Architecture plays its part, good architecture plays its part significantly in both of those things. We need to be able to get fast, efficient feedback on the quality of our work. We need to work so that we can make progress incrementally and iteratively, and we need to build modular systems so that it can work on one part of the system without breaking other parts of the system, and so on. And I think those are in Alan Kay's talk, he said part of his definition of software engineering was that software engineering, he said, in general, was about making things and repairing things in principled ways. And I quite liked that as a takeaway. And I think that the things that I'm talking about in these optimizing for learning, optimizing for managing complexity, are principles on which we could start to build a genuine discipline for software engineering in our profession. And I think we need it.
From my perspective, it's really tempting to to apply that same technique to software where we do all the design and we have a very predictable way to build the thing that we want to build. And you're right, that's how many building projects work. There's a great talk, again, I think at a GOTO conference actually, by Mary Shaw, and Mary works for the Software Engineering Institute, and she does this whole interesting comparison between the building world and the software world. And she basically says software is not engineering yet, cure your stuff. And she says we're still in the early craft and artisanal phases. Yeah. And again, a lot of that's because it's a very immature industry. We are learning a lot as we go along. Technologies are changing. And I don't think we've found some of those underlying fundamentals and principles yet that are broadly applicable regardless of the technologies and the techniques that we're using to build our systems. I think what's interesting is once you start to factor in things like continuous integration, continuous delivery, DevOps, things like continuous testing, fitness functions. So there's a whole concept of fitness functions in the Building Evolutionary Architectures book. And that's the same thing. It's when you are, I'm not a building architect or a structural engineer, so I might have this completely wrong, but my idea is that when you design a structure, you have to do the modeling on the structure around stresses and strains and load weights and all that sort of stuff to make sure it doesn't fall down. And for me, fitness functions are a way to start doing some of that. So if you want to build something that's very low latency, you build yourself a bunch of fitness functions that assert whether you can hit those latency targets, for example. So yeah, I'd like to see more teams doing stuff like that. The downside is it's hard and it takes effort and it costs money. And you have to get some benefits of doing it.
I think we in our industry have a dramatically significant advantage in that if you're building, a bridge or a building or something like that, you probably computer model it to do all of that stress calculation, all that sort of stuff, and you'd test the model and all that kind of stuff. Our model is the real thing.
Yeah.
So there's no empirical discovery that's required after that. The other significant, magnificent advantage that we have is that production for us is free. So once you've done all of that discovery and learning and design, and you've got your sequence of bytes that represents your system, however big or complicated or distributed it is, you press a button and you clone those sequence of bytes for essentially free. And I think that's a dramatic advantage that we have. And so I agree with Simon that software development in general is not yet an engineering practice, but I think that we do know some of those principles. We just haven't pulled them together.
Yeah. I think if you go back a number of years, people tried to create a model, so not the real code. They created a model of the system they wanted to build, and they tried to run simulations on it. So when I went to Dubai a number of years ago, what's it called, the Burj Khalifa, the big tall building. There's a bunch of models in the basement that show you how they modelled things like wind flow around the various sides of the building. Right, that stuff you need to do with buildings because you can't stick up the Burj Khalifa and then stick in a wind tunnel. That's not. It's not I mean, you could do, but it's not worth doing. Yeah. And I think 20 years ago, we tried to apply that same technique. Let's model the software without building
it's the wrong way around.
And simulate it. And you're right. Yeah. Production's free. We can just test stuff.
Because that's the biggest difference between the two worlds, right? If your building fails, you're looking at the cost of constructing a new one. Whereas in software, you can make changes to something you already built without sinking the whole cost again into the same project.
Hopefully.
Well, most of the time.
That's the other key difference to my mind, between software engineering and development is that software engineers is starting off thinking, oh shit, this is going to go wrong. Sorry, I shouldn't have sworn.
It's usually going wrong.
Oh damn, this is going to go wrong. Because it usually is. And so starting off trying to think about the ways in which our system can go wrong, I think is really important, because that's how you do a good job.
I think that's the best tip anyone has ever given me. It's whenever there is a fire in production, step up and be part of the team that investigates, because those are the days that you learn so much about what you shouldn't have been doing.
Yeah.
I did some consultancy for a bank a few years ago, and they asked me to advise them on building resilient systems. And we kind of walked into this room, and we were all sat there, and we hadn't met before, this room full of people, and everybody was a bit reticent to start talking. So I just said, well, if we're building resilient systems, we're going to assume that everything's going to go wrong from the start. And they said, what? We assumed we had to make sure it didn't go wrong. I think engineering is about assuming stuff will go wrong, and then you learn from that.
Yeah.
And predict ways that it might go wrong and defend against that. Another callback to Alan Kay's presentation where he talked about Facebook and their outage and the kinds of things that they should have been doing to avoid that kind of outage.
Well, as with any outage, you only learn what you should have been doing when it goes wrong.
Yeah.
And luckily, most of the time, it's fixable. Just not always behind the scenes, so that nobody notices.
Yeah.
All right. I think we can wrap up there. Thank you so much for joining us today and for the interesting takes on a lot of things. And enjoy the rest of your conference.
Thank you.
Pleasure. Thank you very much.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.